Hello, everyone. Welcome to the Vedic Astrology podcast. My name is Fiona Marks, and I'm delighted to be here hosting the podcast episode with you. Today, I have a friend and colleague with me, and we are going to be exploring a conversation between Vedic astrology and astronomy. And this conversation is not perhaps the most common conversation that you see when astronomy and astrology get put together, which is usually some kind of debate where one side is trying to convince the other side that one side is right or one side is wrong. Today's conversation is much more about learning a bit of astronomy or reminding ourselves of the astronomy that is embedded in Vedic astrology that we're looking at every day as part of our work and our interests. So I have invited to join me Stephen Jones. And Stephen, would you like to say hello to our listeners, please?
Yeah, thanks, Fiona. Hello there. I'm Stephen Jones. I would guess I would classify myself as an amateur astronomer, which is a large and illustrious group of people. There are many amateur astronomers all over the world. And primarily, I am a teacher. I've been teaching secondary school-age children for 30 years now. My degree is in physics, but I took an awful lot of astronomy courses. And over the 30 years, I've been teaching astronomy at GCSE, at A level, and IB, the International Baccalaureate level as well. So physics, I guess, is my job. Astronomy is more my passion, I would say. So hopefully I can bring that context to this conversation.
Thank you so much, Stephen. I'm really honored to have you here today. And can you share a little bit about your interest in astronomy? How did that begin for you? And what is it that inspires you most about astronomy?
Wow. I mean, my mum jokes that my interest in astronomy started at only a couple of weeks old when the Apollo 11 moon landings took place. And apparently, my mum sat up all night and sort of held up my chubby little face towards the TV screen and went, "Watch this, Stephen, it's important." So at a couple of weeks old, I was watching the moon landings. Who knows, subliminal things perhaps have gone into my brain at that point. I suppose interest in astronomy, as with a lot of people, I guess started with science fiction. I always remember being a bit of a sci-fi nerd, watching the original Star Trek on a black and white TV that we had, and watching Star Wars at the age of 7. These were real seminal things in my life. But I think I can probably trace the real passion for astronomy as being something special, something different, to watching the original series of Cosmos back in 1980. So I would have been age sort of 10, 11, which was narrated by Carl Sagan, the great, if I may say, Carl Sagan, a real fantastic communicator of science and astronomy. And that TV show really opened my eyes. He placed astronomy as not science fiction, but had these in wonderfully exotic sort of ideas and, introduced me to white dwarfs and red dwarfs, red giants, black holes, quasars, galaxies, these things that sounded like science fiction, but were not. These are observable phenomena. But he also put it into a context of human history. And so it wasn't something separate. Astronomy was something very big, but it was also something incredibly personal. And that really resonated with me. And I think that really got me interested in science itself. The thing that I guess keeps me sort of interested in astronomy particularly, but also in physics, is that sense that astronomy is so much at the edge of knowledge. There's so much that we still don't know. Professor Brian Cox, he talks about this idea of, a scientist can't be any happier when there's something they don't know. And it's that sense of, oh, we don't know what this is. Oh, that's great. Let's see if we can figure it out. And that almost the celebration of I don't know. I mean, I often ask my students in class, and I sort of ask for an answer. And if somebody says, I don't know, my usual response is greatest answer in science. And so the fact that so much of it is unknown, I think is absolutely fascinating. And also the way that astronomy looks at the cosmologically huge and the small, I find absolutely fascinating. To understand stars, we need to do massive galactic scale gravity equations, but we also need to understand quantum mechanics. And so the way that astronomy brings in the big and the small is wonderful. And also you don't need anything special. You can just go out, look up, and you're an astronomer. And I think that is also one absolutely wonderful thing about it as well.
Stephen, as I'm listening to you, I can really understand why we're on this podcast together today, because so much of what you're describing is also how I feel about astrology, that it's so large, it's so enormous that the things that we're looking at are laid out in space in such vast distances from where we are. And at the same time, the very art of being an astrologer is connecting that to the incredibly personal and to the grounded experience here on planet Earth. And one of the things I found learning astrology was that stretching of my mind, stretching of my concept and imagination of how large and interconnected everything is. But I really came to an astrologer with no interest in astrology, much more an interest in astronomy. And I also remember as a high school student, when we finally were studying astronomy, really feeling like this is what science is about. This is what now I'm really being exposed to big science. So I think it is an incredibly inspiring field, and it has been inspiring for humans throughout history, hasn't it? This thread of humans all over the world looking up at the sky and being inspired by the movement of the fixed stars and of the planets. So we are part of a very long lineage of many, 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 many humans who've been inspired by space.
Yeah, Fiona, I sort of have a view that astronomy probably is the oldest science. That's a subjective point of view of mine. If we go back thousands or tens of thousands of years, the concept of science didn't really exist in the way that we think of it. But I sort of think that the early Homo sapiens and even earlier sort of the human species must have looked up at the sky. And of course, the sky at night, before all this light pollution, must have been a thing of awe, a thing almost to be frightened of, but also to be in wonder of.
It really is. And it does inspire wonders, and it inspires the I don't know that you were highlighting. That is actually a very powerful place for humans to be, when we can be comfortable in the I don't know and have that exploratory mindset. Then that's when we really learn, and that's when we're really open to new knowledge and to understanding complexity. So the sky gives us that every night. And yeah, it must have been like cinema, just watching. Yeah. Another great interest that I happen to personally know of Stephen Jones is cinema. So I can see a link between the night sky and the cinema too. But speaking of links, you and I, with our titles on of astronomer enthusiast and astrologer enthusiast, would often be at opposite sides of the table. However, astrology and astronomy were originally, we could say, linked, or can we say the same science? Can you share with us anything about the background and history of the connection between what we now call astronomy and what we now call astrology?
I mean, I'm no historian, so I would say that straight away. But certainly, if you look back, there wasn't really a difference. The way that you would go about measuring the stars, and certainly we can go back to the Greeks, the Persians, these people who looked at the sky, who measured the sky, accurate measurements of the positions of the stars. Certainly more than 2,000 years old, there are star charts, with accurate ways of measuring. And you can do some incredibly simple measurements with a few pieces of wood, and angular measurements between the stars were taken. So this sense of looking at the sky, measuring the sky and trying to understand the sky, there really wasn't any difference. I mean, people like Newton would draw up an astrological table for you. Newton, I think he's correctly viewed as being, one of the fathers of modern physics, I suppose, in how you would view it. But to modern eyes, he was involved in some rather unusual things and would dabble in alchemy, for example, and again, alchemy and astronomy, which to modern scientists would seem a little unusual. But certainly there was this time where they were really the same thing. I mean, the zodiac is a term that I know you will use in astrology, but astronomers today will talk about the zodiacal signs and they will talk about constellations. And so a lot of the language is very similar. I suppose a separation begins in the time of the Enlightenment, taking a very sort of Eurocentric Western view, the Enlightenment that happened in sort of the 17th century or so. The view that the stars could somehow have a direct impact on the lives of people on Earth was seen as being something very separate, and having a very mechanistic view of the universe started to come into play. The development of science as something that could be measured, something more empirical. I guess that's really around that time is where astronomy and astrology started to part ways, I guess.
Yeah, it's interesting, isn't it? Because that age of enlightenment that you're speaking about, I guess, was trying to remove superstition as a main part of doctrines or of thought, of wisdom. I guess the aim of the Age of Enlightenment was to remove superstition, and astrology kind of came into that field where science is stuff that you can objectively observe, prove, sort of experiment and repeat your data. That's if we can marry ourselves to that method, we will weed out superstition, and then we will just be left with, like what you're talking about, empirical facts that we can rely on. Rationality.
Yeah. It's very difficult to simply separate it out. During the time of Enlightenment and this view away from superstition, I mean, with some people that meant a distancing from organized religion as well. You will find people who viewed the traditional Christian Western view would be, well, actually religion is part of superstition as well. And so you get these developments over time. And certainly you will find scientists and astronomers today who will have religious beliefs. And so it's not quite as simple as that there is an absolute split, that there is only one way of viewing the world and another. And you get individuals who will have personal beliefs and will have scientific method. And so there is a very interesting little mix that goes on there. It's quite complicated, actually.
As humans are, we are really complex, aren't we? But I think it's interesting because when one is on this side of the world, the astrology side of the world, one can look at that Age of Enlightenment reliance on the scientific method, and one can be a bit disparaging about it because it disregards intuition, which humans experience a lot of intuition. They have a lot of feeling about the way something should be or whatever. And the scientific method or the Age of Enlightenment or that kind of mindset sort of said, hey, let's stick with what we can observe and we can prove. And if one is more on this side of the world where, yes, energy and intuition and messages, or, we could go as far out into that world as we want to, you can look at the Age of Enlightenment and think that there was a lot of throwing the baby out with the bathwater, that we devalued a lot of things that were important. But I have to say, also, as we're going through modern times right now as a parallel, when you see what we've been going through in the last, particularly highlighted in the last 5 or so years, this idea around fake news and the way people can espouse whatever they want and claim it's truth, and people believe in that and they take actions based on sources of information that they think are true and that they should believe in. You can realize the importance of removing superstition and trying to get closer to a truth that is observable and provable, because living in a world where everybody gets to say whatever facts that they want and claim them to be true and defend them to the death and to the death of other people is very scary as well. So I can see the need for the Age of Enlightenment, even though I do feel there was some throwing the baby out with the bathwater.
I mean, we're probably actually heading almost into a completely different podcast here, so I will only just stray briefly onto this. But it does seem to be the case, not exclusively, that if you want to find somebody who is absolutely certain of something, it wouldn't be a scientist. I'm very much about show me the data. And I suppose this is where we may have a slightly different point of view. I do see the value in some of these things you talk about in terms of like intuition and such. Some of the great leaps in science have been sort of come about by people having intuition. Science is carried out by human beings with all the foibles and issues that human beings have. So Science doesn't exist in some sort of bubble. It is a process carried out by people. But yes, science, when it really comes down to it, it doesn't have a lot of place for ideas like intuition. Intuition can be very useful, but in the end, it is down to the data. And I guess that fundamentally is where the differences are. I would always say that show me the data, and I'll be like, yeah, fine. It could be a deeply held belief that I have or opinion that I have, but you show me the data and I will go, yeah, fine, okay, let's go with it. I know that astrology is a very broad church, if that's I'm mixing my metaphors here. It is a very broad church. Some of the predictive elements within some branches of astrology, I think I would find difficult to get with. I will be very dull and boring and go, show me the double blind test and I will get with you, which I accept that's not really, in a sense, what astrology is looking at. And it does have a different perspective. And so there will be some elements of it which I do find more difficult to get on with than others. Science has brought up some radical ideas around the turn of the 19th, 20th centuries when we had the development of quantum mechanics and relativity. This really shook the foundations of what classical physics was. There were honestly people who thought, at the end of the 19th century, all the physics is discovered. We've done it. The great James Clerk Maxwell and these electromagnetism equations, just really incredible work. And they really thought everything was been discovered. And ideas within quantum mechanics and relativity are very counterintuitive and seem to be contradictory to the lives that we understand today. When I teach my students quantum mechanics, often quote what a lecturer said to me at university, in that if you think you've understood it the first time through, then you probably haven't heard a word I've said. And it is something very counterintuitive. And so it seems like you can come up with, in some ways, any sort of bizarre idea, and it's like, okay, well, we can accept it. But even quantum mechanics, which challenges the way that we view the world, there is a basis of theory and mathematics behind it that does separate it out from other ways of viewing the universe. And I guess astrology is another way of viewing the universe. Religion is another way of viewing the universe. What separates science, it is much more an empirical system. You're right in that respect. Give me the data and right, we'll go with it. And I think that's what does separate it.
Yeah, I'm sharing my screen with Stephen. And of course, I put up a chart with all of the data because astrologers are not just saying, oh, your sun is in Gemini and therefore you're this kind of person. That's when we read a horoscope in the newspaper, we tend to get that impression. But a working astrologer is looking at a lot of data, whether that data is valid in having anything to say about a person's life. I think Stephen and I could talk for weeks about that. But what's interesting, is that the data is largely based on the positions of the planets in space, which is what we share, this common heritage that we share, and observing of these moving bodies. And through the differences in those moving bodies, how fast they're moving, at what point in the ecliptic they are, how far north or south they are of the equator, all of these things is what an astrologer is taking into account in looking at the person's life at this point in time or at the time that they were born. I think astrology is a really interesting mix of this mathematical, scientific, lots of numbers, and yet then, perhaps the questionable bit is that intuitive leap where we say, well, that describes the kind of person who experiences this, or it describes the kind of person who experiences something else.
The sky, the universe, does have a tangible impact on our lives on Earth. It does. I mean, if you want to talk about certain species of animals that will start to spawn when a full moon appears at a certain point in the year, this is not fanciful. This is empirical. This is very much measurable. The positions of the stars in the sky and the moon, certainly the moon does have this very specific impact. On Earth, we are very much driven by what the sun is and what the sun is doing. The tilt of the Earth, the way it generates the seasons, these are all important. I mean, we talked a little bit earlier about the ancients. I'm not an Egyptologist, but my understanding is that the Egyptians did recognize that when certain constellations appeared at certain points in the sky, then they knew that the Nile was about to flood, and the flooding of the Nile and the sort of the water and the nutrients and the silt it put onto the ground, that meant that people could actually eat and could live. And so it's not surprising that we see this connection. I mean, here on Earth, we are, if I can quote Carl Sagan again, we are made from stardust. The iron in our blood was formed within stars billions of years ago that went supernova and exploded. And during that supernova explosion, iron was generated by nuclear fusion, and that iron is in our blood now. The oxygen we breathe was generated inside stars. The carbon that makes up the biology on Earth was created by stars. So we are intrinsically linked with the universe. We absolutely are. We are linked by the particles that we created. We are linked gravitationally by the solar wind and such. So scientists are not saying that we are not connected with the universe. We absolutely are. I guess it's how far that connection goes is where we have this interesting line.
Exactly. And I'm so glad you brought up the stardust, because I was going to ask you that. That always blows my mind. That level of connection that we have with the universe is something that in the day-to-day one forgets and sort of gets wrapped up in a mundane reality. And then when one is reminded that the oxygen we're breathing and the iron in our blood has come from this massive dynamic events that are happening in space over just time periods that we can't even really wrap our minds around. I love that stuff. So yes, you're right. We could spend hours in the gray area, but there are many things that we agree on. And even what you're saying about Egyptian, we have so much that we owe to the Egyptians and then various cultures moving forward. But those cultures didn't necessarily bring that astrology connection to the personal. They might have brought it to the timing of significant events for the culture or the society or for festivals or for hunting, but they didn't necessarily say, oh, this means that this child is going to be rich or this child is going to be poor. It wasn't necessarily a personal tool. And that is something that is another philosophical difference between us and the ancients, perhaps, is that these days humans are very interested in their self-development, their individuality. My experience as the self is a huge part of my reality, whereas in the past there might have been not so much individuation, not so much obsession or focus on my individual fate or my potential to grow as an individual. There are these waves of different human development of what humans are interested in, and it has many parallels with science. Actually, we've talked about a few of these big, I'm going to say earth-shattering. I don't know whether that's very good, but there are some big scientific observations that change the way people view themselves and their place in the universe. And maybe one of the first major ones that we think about is this acceptance that the Earth goes around the sun rather than the sun going around the Earth, right? That is earth-shattering or concept-shattering when humans, when the church, when religion, faith, whatever, accepts that the Earth is not the center.
I think this is such a good one, of course, to bring out. You know, the Ptolemaic view of a geocentric universe, that the Earth is in the center and everything orbits around the Earth. The Earth is the center of things. It is the most important. This is a very good lesson to modern physicists, and that there's almost nothing more dangerous than an idea or a point of view that is accepted without question. Everything can be questioned. This is the thing. This is a falsehood that people think about physicists. It's like, oh, well, it's completely fixed. It's absolutely not. But you can't just suggest whatever you want. You can come up with any sort of left field idea you like. But if you don't have the empirical data to back it up, then that's where it's not science. There were Greek philosophers who thought that the sun was at the center and that the Earth and the other planets went around the sun. So this idea of a heliocentric, sun-centered view of the universe certainly goes back a long way. And as you say, you have people like Copernicus and Galileo who started to suggest these things. But again, they were suggesting them from empirical data. I mean, Galileo, with his early telescope, looked at Jupiter and saw points of light shifting position night after night, and realized that what he was seeing was moons of Jupiter. And even today, they're still called the Galilean satellite, Europa, Io, Callisto, and Ganymede, the 5 largest moons of Jupiter. And it was an empirical observation that sort of went, well, hang on a moment. If the Earth's the most important thing in the universe and everything orbits that, then we've actually can see things orbiting something else. So maybe the Earth isn't as important. He observed phases of Venus that can't really fully be explained if the Earth's at the center. And even when people started to accept the ideas of Copernicus and Galileo, scientists introduced ideas, these things called epicycles, and the epicycles were created to try to sort of fix problems in the science. I know retrograde motion is quite an important concept within astrology, and retrograde motion plays a really important historical part here, and the fact that every so often the planets would appear to be moving against the background stars. The background stars appeared to be fixed. They're not. And if we have time, we can come on to that later. But the planets were moving against the background stars. And the planets were basically moving through the zodiacal constellations. But occasionally, the planets' motion against the background stars would stop, they would reverse, and then go forwards again. And this was a real problem to explain this. And so scientists invented, if you like, this term called epicycles. It's a bit hard to explain without pictures, but basically what an epicycle was is that you can imagine Mars, for example, which was orbiting the Earth as what was believed. But actually what Mars was really doing is that it was actually going in a little circular orbit, and that circular orbit was then orbiting the Earth, and that's what the epicycle was. And so every so often, depending upon at what point the orbit was, you might actually catch Mars moving backwards. And it solved the problem. And it was like, oh, fantastic. Epicycles has solved it. We've got it. We've got it sussed. But then because of empiricism, because of more and more accurate measurements of the planets, they noticed that the epicycles didn't quite explain the motion of the planets. And so I guess at this point, you either go, well, there's something wrong with this theory. We need to have something new. But actually, they just doubled down in it and went, no, circles are the way of things. Things orbit in circles. That's just the way it is. It wasn't even an argument. So they had epicycles on top of epicycles. And it got to the point, you might have 12 of these little epicycles on top of each other. And it's not really until you come to Johannes Kepler, I'm going to get my dates wrong here, late 17th, early 18th, I think. Someone will Google it and find I'm wrong there. But his observations of the planets along with Tycho Brahe, he realized that orbits were actually elliptical. And that leap to go from the empirical data to then go, actually, planets orbit in ellipses, in a sense, fixed the problem and everything was fine. And again, it was like, we've sussed orbits. And then Newton's laws of gravity are able to explain these orbits. And it's the real classic empirical view of science that if you let the data teach us, then we're okay. But of course, this thing never stops. Accurate observations of Mercury in the 19th century, we actually noticed that Mercury wasn't orbiting correctly, in inverted commas. It wasn't following the pattern that it should do. And then we actually had to rethink gravity. And so we've got Einstein's general relativity equations actually showed us that we didn't fully understand gravity. And when you apply Einstein, then the orbits make sense again. And this is the constant development in science. You have these new ideas come about, but the empirical data will always bring us back. And retrograde motion is still a really important thing. I observe it myself sometimes as an astronomer, and actually will watch over a series of months, Mars move across the sky, stop, go backwards, and then move forwards again. I mean, these are just wonderful parts of the sort of the celestial ballet, not to sound too pretentious, that the planets do.
Yes, but it is wonderful. And I absolutely agree with you that it's our own limiting concepts that create these conundrums, problems that have to be band-aid fixed until we actually relax and open our minds to just observing the truth, and then, not imposing our ideals on the data, just let it be. Yeah. So this was a big moment for humanity. what it must have been to be a human thinking one was the center of the entire universe. Like that's a philosophical place to be in relation to all knowledge. And then to be a human who realizes maybe I'm not as significant. I'm a planet orbiting a star, and there's actually lots of stars, and there might be other planets orbiting stars. There might be other life. It really changes the importance of being a human. And these things continue. Science really helps us open our minds, open our eyes, but it changes our relationship with an integrated view that we're the most important thing and everything is about us and everything's connected. So that, I think that's really significant when humans as a culture decide that they're not the center of the universe. This is big. But there are other really big things that science also changes the way that humans feel about things. For example, atoms. To realize that we're made up of these tiny dynamic atoms that actually have more space between the bits of stuff that's in an atom than they have stuff in the atom. You could imagine as a human before this fact that we think, well, I'm made of solid stuff. I can feel how solid I am. I can feel how solid the table is. It must be more and more dense. Like the more the microscope looks at it, it must get denser and denser. But actually, at a certain level, we begin to see that there's a lot of space in between what makes up the atoms that make up the. And this is conceptually enormous again, right? It changes humans' relationship with.
There absolutely is. There's a wonderful thought experiment a Greek philosopher, I think it was Eratosthenes, does, where he talks about having a stone, and in this thought experiment, so it's not an actual experiment, he imagines having a hammer and a chisel and breaking the stone in half and throwing half away. And then the half he's got left, you sort of break that and then you throw half away. And then the bit you've got left, you break that and you throw half away. And he asked the question, well, can you keep doing that forever? I mean, what an amazing thought to have.
Yeah.
2,000 years ago, he had this thought. Can you keep going forever? Or do you get to a point where you reach something fundamental? Now, he had no empirical data, but he basically went, well, I guess I make a prediction, if you like. I'm not sure if prediction is the right word there, but certainly his hunch was, I think everything is made up of things which are fundamental. And this concept of atoms, I guess you could probably take back to that. And this concept of how small you can break things down and what is the bottom is still a live idea. Atoms certainly were thought to be fundamental. And then, as you said, Rutherford and these experiments he did in Manchester in the early 20th century brought about the idea of the nuclear atom, as you said, that the atom is mostly empty space. And then we realized the nucleus was made up of protons and neutrons, which was radical. And then we realized, again, from empirical data, that protons and neutrons actually made up of even smaller particles called quarks. I can almost hear Eratosthenes sort of going, okay, let's get the hammer and chisel again. Can we smash it? Is there anything smaller?
That's right.
And it's the questions we keep asking. And it is radical to consider this. You know, when I say to my students, if you touch a table, there isn't actually anything physically in contact there. It's just electromagnetic fields between the atoms interacting, producing an illusion of what we think of things as being solid. And these are quite radical things to push against your mind.
Yeah. And I think it then continues as well with biology, doesn't it? The DNA, that this amazing experience of being alive and all of these thoughts that I have, all of my memories, my loves, my passions and hobbies, my preferences, whatever, comes down to this DNA, which, you know, neither you nor I are biologists. So now we're really out of our but is a very limited number of elements like carbon and nitrogen and, you know, just, I think it's just 5 elements that just in different combinations make up a coding that allows complex life forms to procreate and pass on this data plan that can then be implemented by another iteration.
I feel that looking at a night sky and feeling that sense of awe, or looking at a sunset or a sunrise and having that sense of how beautiful it is, it's hard to find the science in that necessarily. I mean, I would argue that feeling awe and having an emotional reaction can help with that scientific development. I mean, I guess some people would say, well, actually, our concepts of beauty is really just down to brain chemistry. And ideas of good and evil are really just sort of human constructs that can be taken down to sort of fundamentally brain chemistry and psychology. And maybe you can break those things down. But of course, sometimes something is just beautiful. And that's valid as well.
Yeah, and it's kind of, nature is beautiful, isn't it? The night sky there's something for humans that we find beautiful about the night sky. There's something we find beautiful about being made of stardust. There's something beautiful about a table being made of space. It's all of these, the fundamental realities of nature are very awe-inspiring and almost religious. We're sort of, again, you come full circle that true science, like really observing nature, is awe-inspiring and has that larger than life, larger than my mind kind of experience. But all of that we've been discussing, how science helps us to look that awe in the face, which is, I think, what humans really enjoy doing, all of that science has had the effect in the Western European tradition, which is what we've both grown up in, of separating humans from their sense of being the center of everything. So we got separated from being the center of the universe, because it turns out that things don't revolve around us. But then we also got separated in other ways by this discovery that there's more space than stuff, and also this discovery that we're made up of a chemical coding. All of this amazing experience is chemical coding. And in some ways, this is what leads us to be so driven around our individuation and wanting to find out, who am I and where do I fit? What should I be doing? I feel lost. If we had that certainty that we used to have, that the earth is the center of everything makes sense, then we don't feel so much angst. But when we're actually in the scientific space of I don't know, which is where we started this conversation, how powerful it is to be in the I don't know, it can leave people feeling lost and that they want more certainty. And that's, interestingly, what can drive people towards astrology, that they want some kind of sense of meaning or sense of pattern, or understanding the pattern that seems to be part of this randomness, but this awe-inspiring randomness. The ancients had a very solid faith or ideological system that gave them a place in the world. And empirical science has allowed us to step more and more into the unknown, which is wonderful, because that's where we discover stuff, which is awe-inspiring. But in that unknown, we can feel lost and disconnected from a sense of meaning, a sense of belonging to the universe. And so perhaps it's interesting how science drives some people towards astrology, or maybe other, drives them towards faith, drives them towards psychology, that humans want meaning as well as empirical observations. There's something about the human mind that wants meaning.
Yeah, it's a tricky one, isn't it? I mean, you're right, certainly within the Western world, at least, a move away from perhaps organized religion perhaps is being replaced by other ideas. I'm not sure I feel necessarily very equipped to discuss that. I mean, we're almost heading into sociology as well here. But of course, certainly, a belief in something greater than oneself, whether or not you call it religion, is prevalent in other parts of the world, away from the more traditional Eurocentric Western view of things. And so people's experience of sort of religion or astrology, I think, probably does vary massively, doesn't it? From where you live in the world, where you're brought up, your cultural influences. But certainly in the West, I think, the move away from organized religion, perhaps does result in people looking at other ways of viewing the world around them. For me, science as a process helps me make sense of the world.
Yeah.
And that sort of very empirical way of viewing things leads me to sort of make decisions and create viewpoints about the world around us, whether it's politics or whatever else. But like you say, fundamentally, whether it be astrology or religion or science, there are ways of trying to understand the world, understand the universe. And I guess I'm more open-minded than I perhaps was. I still fundamentally am an empiricist. And you won't be surprised to hear me say that as a scientifically inclined, empirical inclined person, I still think that science and its tools are going to be the most helpful ways to view some of these big questions. I think what I have become more open and accepting of is that self-reflection, I think, is very important. And there are lots of ways to reflect on yourself and your place in the world. And I do understand, and I know, Fiona, you're very good at this, in that the astrology which you study and practice and help people with, it's so much about self-reflection as is it about anything else. And I think if astrology can help people with self-reflection, then great. It's not necessarily a system that I would find useful, but I absolutely do recognize that many people do.
Yeah, it's really interesting that you say that, Stephen. I definitely feel that I come more from a scientific world than a intuitive world into astrology. So it's been a very interesting turn of life events that I find myself here as a Vedic astrologer. And I can't explain all the ins and outs of how it works or if it works. But a lot on the Vedic Astrology podcast, we have touched on astrology and music a couple of times as a theme. And perhaps I find it a little like that music is so complex. Intuitively, people understand music. The first time they hear a piece of music, it has an impact on them or not, but there are definitely pieces of music that have an impact on someone who's never been exposed to that piece or never been exposed to that style of music, and yet it communicates something. And astrology, on some level, for me, as a more scientific brain than coming into astrology from a heritage of understanding it, it seems that it is a tool that can describe the music of one's life, can look at the harmonious elements and the elements that are out of harmony, and that conversation about the harmony and the disharmony, the actual experience of this person's piece of music, can be enlightening for a person, can help them have perspective and perhaps feel more empowered, more authentically themselves, which allows them to make better decisions. And then whether that has to do with the position of Rahu and whether Mars was retrograde or not, that then you and I can do our double blind studies, and that will take the rest of our lifetime. And instead of taking the rest of our lifetime to do that today on the podcast, let's dive into some of the shared heritage between astrology and astronomy, because astrologers may not realize that they're using a lot of the similar terms from this shared heritage. So the ecliptic, that is fundamental for astrology because it is the pathway that these moving heavenly bodies travel through, the ecliptic and the zodiac. Are these terms that are still used in science today? Do they mean anything?
Oh, yeah, absolutely. I mean, the ecliptic is, in astronomical senses, it's quite an interesting one because you can very much view it from two different perspectives. If you could imagine taking ourselves on a journey, which at the moment technically will be very difficult, that we were somehow able to be almost like outside of our solar system and sort of almost like looking down upon it, we could view the Earth orbiting the sun in an ellipse, of course, very, very close to being a circle. It's not like a really stretched out oval, but it's close to being a circle. And the plane on which the Earth orbits, remember old style record players, although they're very much back in fashion, aren't they? But if you think of a record being on that circular plane and the Earth is sort of like orbiting around the edge, so you get a record player in there, a little bit of Tipex, and you put a little white mark at the end of the record and something you don't mind destroying, and you set the record player going, and that little white mark moves around. That white mark would be the Earth. And so you can view the ecliptic as this plane, this flat plane which the Earth orbits around. And of course, the other planets in the solar system, they orbit very close to the ecliptic, but they're not all on the same angle. And so the inclination of the planets to the ecliptic can vary slightly. And so that sort of outward view, I think, is a very useful one, and astronomers will certainly think about this. And looking at the inclination of the different planets, minor planets, dwarf planets, comets, and such, to the ecliptic is a very important thing. But then, of course, we can view the ecliptic from a geocentric point of view, from an Earth-centric point of view. And if you then look outwards at the sky, so astronomers talk about this thing called the celestial sphere. And the celestial sphere, again, is quite an ancient concept, but is something we still basically use today. So sitting on the Earth, it is like we're at the center of a large sphere. And the stars and the planets are almost like they're sort of painted on the inside surface of this sphere, and we're sort of sitting in the center of it. And if we were to mark the position of the sun on this sphere, then every day, well, every second, but every day, as the Earth orbits the sun, then the relative position of the sun is going to shift. And so if we mark the position of the sun against the celestial sphere during the course of 1 year, which we define as the time it takes for the Earth to go around on its orbit once, that line which is drawn on the celestial sphere is the ecliptic. And again, that is a very useful thing as well, because the whole measurement system within astronomy is based upon the ecliptic. Now, the zodiacal constellations then are the constellations which basically sit on the ecliptic. And so that we talk about the zodiacal constellations. There are many other constellations as well. By the way, the term constellation in astronomy is just a patch of sky. The patterns themselves are called asterisms. And so there is a patch of sky, a constellation, which is given a notional name, whether it be Libra or Gemini or Orion or such. But the name constellation is just for this patch of sky. Now, within it, then, we will see these asterisms. Of course, the positions, the asterisms, the patterns in the sky sometimes don't necessarily sit particularly well within the constellation. And over time, the positions of the constellations and the asterisms have shifted slightly because we're in a very dynamic system. Does that explain the question?
This is fantastic. So yeah, I think this is where astrologers, we love to have an astronomer to sit down with and dissect or really examine these pieces of information. So to recap what you're saying, the word ecliptic makes perfect sense in an astronomer world as well.
Yeah.
The zodiac constellations make sense in astronomy language too. And interestingly, we could even get away with saying celestial sphere to an astronomer. That would mean something. Okay, great. So good. And then it's very interesting what you say about the zodiac constellations marking a patch of space, not actually the star pattern. Yeah, because can you tell us a little bit about how that patch of space that we might call Aries has maybe moved slightly so that the star pattern Aries fits into it differently than it used to? Why does it move from our perspective?
Yeah, so we have this effect called precession. This is one of these things where the best analogies don't really mean that much today. I don't know if children even know what a spinning top is anymore. But a little device, it's not a sphere, it has a little pointed bit on the bottom, and you could set it spinning and it would sit on the table spinning and it wouldn't fall over. You get the same effect with gyroscopes as well. And gyroscopes and spinning systems will do this thing called precession. There is horrendous mathematics in this, which I attempted to study at university and never really got my head around. But these spinning systems will do this thing called precession, where they will gradually, if you imagine the object spinning and it sort of has it's almost like it has an axle, and the direction which this axle points will actually trace out a circle. And so as it spins, it will actually gradually change its position. Now, of course, the Earth doesn't have a pivot. It's not sitting on some sort of pivot, but it still does this thing called precession. So the 23.4 degrees that, again, a lot of people may know about, and the Tropic of Cancer and the Tropic of Capricorn are, of course, related to this 23.4 degrees. This is the angle of the, if you like, axle which the Earth is spinning around. So the Earth is spinning, and if you drew a line from the North Pole to the South Pole, then this is sort of like the line of the axle which the Earth is spinning around. And geographical North and South is defined by this spinning. Now, the angle of this spinning is at 23.4 degrees to the ecliptic. So if you think of this plane of the solar system, the Earth is like tilted at 23.4 degrees to this. And gradually over time, over millions of years, precession is taking place. And so where the North Pole of the Earth is pointing at the celestial sphere is actually gradually changing over time. And this will cause a shift in the positions of the asterisms and what we would think of in the sky. And so this is how you get these sort of variations. And certainly when people look at what the sky looked like in the times of the Old Kingdom, in Egypt, for example, you do have to start applying corrections to the positions of the stars in the sky, because they would have been in slightly different positions as this precession takes place.
Fantastic. This is things that they're hard to get your head around as an astrologer, and yet they're really visible and important, the work that you're doing.
Of course, all the planets are orbiting, their orbital planes are different from the Earth, but also the axis of which they spin, they also are different. And so Uranus, for example, is like tilted over almost by 90 degrees. And so these axes of rotations can be very different for the different planets. I assume the axis of rotation of the different planets doesn't form part of astrology.
Not that I'm aware of. Not that I'm aware of.
I guess
Yes.
because it would have been very, very difficult to observe this in the past. It's not something that got integrated into the concept, perhaps. Okay.
But there's so many fascinating things to follow up here. Maybe one of the first things to kind of lock down is how important the ecliptic is from the Earth's perspective. So talking about, as you described it, if we were to mark the sun for a whole year and see that line that the sun appears to move through, that ecliptic is really important to humans, isn't it? Because it feels like the one fixed, reliable, repeatable, always happening thing in a very dynamic and evolving universe. The relationship of our orbit around the sun stays the same enough for us to be able to build things from that, like our calendar and our sense of time. And as you were saying, even our degree of inclination we measure based in relationship to the ecliptic. So the ecliptic is it the one solid thing?
The thing is, of course, in human timescales, a lot of these things do seem fixed, but that's changing as well because the orbit of the Earth gradually shifts over time as well.
Yes.
Because the perturbation effects, the gravitational effects of the other planets on each other shift the orbits. And so none of it is really fixed.
That's true.
It's all dynamic, but under relatively short timescales and in human timescales, it would seem pretty much fixed. I mean, the stars in the constellations, I mean, the background stars appear to be fixed, but they're not. I mean, as the Earth orbits the sun, for example, our point of view of these stars is shifting slightly. Yeah. And this actually is an incredibly important advancement in astronomy. And it's something called the parallax effect. You can experience the same thing in that if you put your index finger up in front of you, for example, and put your arm out, and then you close one eye and then close and open the other, and then flick between the two, your finger appears to shift position against the background wall. And the fact that stars do this actually enabled us to measure the distance to close by stars. And so, the background stars, which were believed to be fixed, actually we now know are not fixed. And so the whole system is incredibly dynamic, but certainly ecliptic is a very important baseline. It has greater importance actually within the whole way in which astronomers would actually measure the sky. We talked about the ecliptic being this imaginary line over which if you plot the position of the sun over a year, again, it's so wonderful. The celestial sphere, it sort of almost assumes that the Earth's at the center of the universe. It's sort of rather wonderful actually in that we're like, no, the Earth is not the center of the universe, but in terms of the celestial sphere, sort of assumes like the Earth's at the center of the universe. And if you actually look at the equator on the Earth, and the equator, of course, is is defined to be at 90 degrees from the poles, and the poles are fixed because of the spin of the Earth. If you take the equator and you sort of somehow project the equator outwards until it meets the celestial sphere, then you have the celestial equator. And so the equator of the Earth can also like draw this huge circle on the celestial sphere. And what's interesting is that because of the Earth's tilt, these two great spheres are almost like two big hula hoops. They're offset to each other at an angle of 23.4 degrees. And these two hula hoops cross twice on the celestial sphere. And these two crossing points are the positions of the equinoxes.
Yeah.
And the March equinox, the vernal equinox, that point where the two lines cross is very important, because that's the 0 point in something called right ascension, which astronomers use to actually plot the position of objects in the sky. So astronomers will talk about the position in the sky using right ascension and declination, which is just like, it's like latitude and longitude on Earth. And that right ascension measurement is taken from, I think, the first point of Aries, it's sometimes called as well. That right ascension point, of course, is incredibly important because it's fixed by, again, the ecliptic. So the ecliptic is an incredibly important concept within astronomy.
Yeah, it's a really important reference point. And in tropical astrology, it's really important because of what you just mentioned. It gets reset to 0 at that, what did you call it, point of ascension?
Right ascension, that's the measurement system. That's the equivalent of longitude on a map. It's the sort of the left-right measurement, but you need a 0 point. So in the same way on Earth, 0 degrees longitude is taken as being at Greenwich, the Greenwich Meridian, which of course in itself is completely arbitrary.
Exactly. Greenwich, the center of the universe.
And it actually runs right through the middle of a telescope at the Greenwich Observatory, which is sort of, it actually runs right through that. It's all astronomical. Great Britain being the world superpower at that point and throwing its weight around. And the French didn't agree with it for many years. It took a long time for them to agree. But anyway, that's another whole of the story.
Yeah. Yes. Okay. So we share all of that, and the ecliptic is this really important reference point.
Yeah.
And so another thing when we're digging into the ecliptic a little bit, is it luck that the planets are close along that path of the ecliptic? And is it luck that they're moving in the same direction? I'm using inverted commas. No one can see that, but obviously language here begins to cheat itself. But so is it luck that they're close to the ecliptic? Is it luck that they're moving in the same direction?
It's all down to how the solar system itself formed. I mean, the solar system formed out of a huge cloud of gas and dust. The solar system formed about 4.5 billion years ago. And this large cloud of gas and dust collapsed. Gas, when astronomers say gas, they basically mean hydrogen. And dust is basically everything else on the periodic table. Astronomers have some I tell you, other physicists look at astronomers' terminology they use and they wince. Astronomers use terms that it's like dust. Carbon is dust. I mean, the astronomers even talk about hydrogen burning inside stars, and the physicists get irate about this and start sort of going, rolling their eyes. You can't use the word burn, it's an incorrect term. Anyway, astronomy is very old. It has weird terms. We like it that way, though. So as the solar system formed out of a large cloud of gas and dust, and it collapsed gravitationally. Now, the collapse wasn't even. A rotation basically began within the collapse of this cloud of gas and dust. The collapse may have happened because a shock wave from a supernova may have struck it, or it might have been the movement of a close by star. But basically, this cloud of gas and dust had some pushes and pulls on it. And so the whole cloud started very, very gradually rotating. And then gravity caused the cloud of gas and dust to collapse. And in the same way that as if you watch a figure skater on the ice, as they pull their arms inwards, they speed up. It's a wonderful concept called the conservation of angular momentum, which we don't need to go into. But as the cloud of gas and dust collapsed, then the rate of spinning got faster and faster. And then the cloud of gas and dust flattened out because of this rotation. And in the center, the star formed. But the material which was left around it, that is what then gravitationally again formed into all the planets. And so it's no surprise that actually all the planets ended up orbiting around this similar plane, because that's where all the planets got formed out of. And it's more than that. So basically all the planets orbit the same way around. And the vast majority of the moons also orbit in the same direction around each of the planets. And also most of the moons and the planets also spin in the same direction. The sun spins in the same direction in which the Earth spins, is the same direction the Earth orbits around the sun. So it's not fluke, it's not a coincidence, it's all out of how the sun itself formed. If I can just, there are some fascinating coincidences and non-coincidences in astronomy. The fact that the moon looks almost identical in size to the sun in the sky is complete coincidence. The moon is thousands and thousands of times closer to the Earth than the sun, but it's also thousands and thousands of times smaller. So they end up looking about the same. So we can get these wonderful eclipses. But the orbital period of the moon and the rotational period of the moon are the same. That's why we only ever see one side of the moon. Now, that's not a coincidence because of gravitational effects. So some of these things are complete coincidences, and other things actually have very clear empirical explanations.
And let's just ask one follow-up question about that out of my interest. I don't know that it applies to astrology, but what about this 23.4 degree tilt that we're on? You mentioned that Uranus is almost, did you say horizontal?
So if you like, the North Pole of Uranus is like flat along along its orbital plane. Yeah.
And is that then random? That's every planet in its settling process?
Well, we don't know. Most of the planets, that they're not as extreme as that. I mean, when we actually do computer simulations, we see that the tilt of the 23.4 degrees, by the way, is not fixed.
Right.
That changes as well over time. And the fact that we actually have the moon actually gravitationally is a little bit of a brake on that and stops it flying around too much. If we didn't have the moon in orbit, computer simulations show that the shift in that angle would be really big. And over time, that could have had rather huge climactic effects on the Earth. And certainly some people suggest that would have led the process of evolution to happen in completely different ways, and we may not have life in the same way that we would on Earth. Why Uranus is tipped over like that, we don't know. The current theory, I believe, is that it was probably struck by something rather large in the past, and that a large body smashed into it. And again, what is fascinating is that all the moons of Uranus also orbit like at 90 degrees to the ecliptic. And the moons of Uranus are bizarre. They are weird. And a lot of them look like they've been smashed apart and reformed. And so we think there is some large collision. And so the moons orbit around, and also the rings that Uranus has also sort of go in that rather weird direction. It's probably produced by physical effects, but again, we don't know for certain why it's sort of tipped over.
Now, so while we're talking about the ecliptic and observing the planets, let's talk about observing them in the Northern Hemisphere and the Southern Hemisphere, because I was born in Australia. And one of the things I noticed when I moved to Europe is that the moon phases look different to me.
I guess it's incredibly Eurocentric to say that in Australia you're seeing everything upside down, because I guess it depends from your point of view, doesn't it? I mean, what is up and what is down? We can get into a whole thing on that. I mean, in physics terms, down is just the direction which an object in free fall will move, which is towards the center of gravity of the Earth. And so if you drew a line of what in Portugal we call down, that is going to be at a different angle, relative angle to what down would look like in Australia. So if just for the moment we think of the ecliptic and the North Pole we think of as up, let's just go with that for a moment, all right?
Yeah.
Then effectively, if you're stood on the surface of the Earth in Australia, you would look, in a sense, upside down in comparison to a person in Western Europe or in the Northern Hemisphere. And so if you're looking at objects upside down, they will appear to be upside down as well. And so an object moving in a particular direction across the sky from the Northern Hemisphere, it will almost look like it's going in the opposite direction backwards in the Southern Hemisphere. So it's really all down to your points of view. And the Earth being a sphere as well, quite hard to visualize these things. And even I have trouble with this. The fact that the way the moon looks will change from if you see it in the early evening or after sunset, or you see it before sunrise. And the actual moon seems to have almost like rotated, and the positions of the seas on the moon will appear to shift position. But that's because we're not stood on a flat Earth. Yeah, sorry, the Earth is not flat. As we're stood on this sphere, and then as the Earth is spinning, the way we're viewing the moon is actually at a different angle. It's better to do with a diagram. But yeah, all of this is really all just down to your point of view. So yes, certainly in the southern hemisphere, things will appear to be upside down in the inverted commas.
Yes, and so
and the movement of the planets will appear to be in the opposite direction as well.
Yes, so for me, the shape of the moon was a very obvious difference, but actually that points to something fundamentally different as well. That when I'm in the southern hemisphere observing planets as they move each day, it appears to me that they move forward in relative space, whereas when I'm in the northern hemisphere and I look at how the moon moves each night, it looks as if it's moving backwards. So
whatever you defined as
forwards and backwards, yeah.
You could talk about moving west or talk about moving east, but yeah, the positions will be in opposite directions. Yeah,
so transiting planets in the northern hemisphere and transiting planets in the southern hemisphere, it looks like that direction of transit is the opposite from each other.
Yeah, that's right. Yeah, because of the upside down nature. I'm doing air commas here. The upside down nature of it will mean that you'll get a different perspective.
Yeah, and that's nice. We have that in astrology. We have different ways of representing the chart. So in a Western chart, it's represented as a circle, and the transits happen anti-clockwise. And in the South Indian chart, it's represented like a box, and everything moves clockwise. So it's good, in astrology, we even have these different representations of forwards and backwards. Okay, so Len, let's just look at one more topic that shares this common root between astrology and astronomy, and then we will save any of our other explorations for the next time we get together. So the final thing I wanted to ask you about is degrees, minutes, and seconds. So when I look at my astrology software and I see a planet, it's represented for me in degrees. We talked about circles and ellipses and this idea of 360 degrees. When we talk about maps and cardinal points, we also use degrees. And when we're yachting and sailing, we use this. So can you talk about why are these things, is there any reason why these things are measured in degrees, minutes, and seconds? How did that come about?
It's one of these things that it's probably the Babylonians. I mean, it's quite a complex story, and I think there's still some debate on this, but the Babylonians had a base 12 or base 60 counting system. We're so used to metric. Most of the world is used to metric, an idea of everything is all counted in 10. But it's not the only way you can view things. And certainly, 12 is such an important way of actually counting. You've got 12 knuckles on your 4 fingers, and you can sort of count in terms of those knuckles. And then you've got, you can use like the knuckles on your right hand, and then you've got 5 fingers. So you can represent 60 quite easily with your sort of fingers. And this idea of 60 is such important. And 60 is such a great number because it can be split into so many equal parts. And so when they started looking at circles, they split into 360 parts. Now, I've got to say, this is quite arbitrary. The circle does not have to be split into 360 parts. I mean, we could easily just say, well, we're actually going to split circles up into 100 parts, and each equal division, we're going to call it a Jones. And we could just say that.
Yeah.
And as long as we all agree, that's fine. But the Babylonians, they've got this system of 60, you've got 360. I mean, the fact that the Earth takes 365 days to go around once, that was so close to 360, it almost seemed to be like, oh, they're onto something here. And so you've got this idea of 60 being so important, and 12 as well. And again, the Egyptians come into this as well, and Babylonian ideas via the Greek world sort of transmitted through to Egypt. And this idea of having the day split into 12 equal segments was an important one when we started to try to measure time more than just it was day and night. And so, the Egyptians have got 12 hours of daylight and 12 hours of nighttime. And this idea carried on for many, many, many centuries. such that the actual length of the arrow would change during the year. So, for example, certainly in Northern Europe, where day length really does vary in the summer and the winter, the arrow was longer in the summer because daylight, the amount of time that the sun was above the horizon, was split into 12, which is pretty freaky to us now, isn't it? But eventually we settled into this idea you've got 12 hours of day, 12 hours of night, which so you've then got 24 hours. But then you want to split the hour. As our ability to measure time improved, we can actually measure shorter periods of time. And so you can actually split then the hour. And then, of course, well, we split using 60, because the Babylonians gave us 60. That works rather nicely. And so the hour is split into 60. And then the hour is then split into seconds. And so the second, as we have got it today, really comes from astronomy. The rate at which the Earth spins on its axis defines 24 hours, which hence defines minutes and seconds. And so the idea of degrees, once again, comes from they're all multiples of 60. But there isn't something inherently important about 12 or 60 or multiples of it. It's just what we decided to use. I mean, they tried to decimalize time in the late 1930s, early 20th centuries, but it just didn't catch on. There wasn't really anything beneficial. I mean, as a scientist, certainly a European scientist base, metric is such a useful tool. For me, imperial measurements like inches and feet and such, I think are so much more difficult to use. But anyway, that's a point of view. So we've changed to a metric system with most other things. But then we've saw 360, and then the fact that measurements on a map, so you can think about the Earth, of course, as drawing lots of these circles, and these circles can be split into 360 parts, and then you can split these down into minutes and seconds. If you go on modern mapping software like Google, it generally has degrees and then a decimal. And the old way of actually writing down degrees, minutes, and seconds has sort of gone, really. But in astronomy, these ideas have kept on going.
And is this shared heritage of using degrees, minutes, and seconds, is that because that is the measurement of angles? So really, when we talk about anything that measures angles, it's probably going to use this degrees, minutes, second.
Yeah, certainly, our ability to produce maps and to navigate started off with the Babylonians, and it stuck. I'm sure there were probably other systems as well in other parts of the world, but it's almost like a form of natural selection here. VHS beat Betamax. It's something that sort of won out. It's very, very useful. I mean, if you ask a physicist to measure angles, there are other units. Physicists, for example, use something called a radian, which is a different way of measuring angles. And so it isn't an absolute, but it goes right back to the Babylonians. And the fact that time and angles sound so similar, well, this, again, is no surprise. The telescope at Greenwich was looking at the passage of stars across the sky, and stars moving across the sky is incredibly related to time. The passage of our most important star, the sun, is in astronomical sense, is directly related to time. I mean, if you shove a stick in the ground and watch the shadow cast by a stick over the course of a day, you've basically got an early type of sundial. The direction which the shadow moves is clockwise. It's why our clocks, the hands on the clocks, move the way they do, because they move in the same direction which the shadow cast by the sun. So it's another example of how astronomy and the way we look at the stars and the sun directly impact how we navigate on the Earth and how we view time.
I know, this is what is mind-blowing and so satisfying about astronomy, astrology, is this bringing together of geometry, really, is what we've been talking about recently with the degrees, right? Measuring angles, and it brings together time and it brings together space. It does. It's such a great field.
It might be just worth mentioning at this point, in that, because again, you could perhaps tell me how this works in astrology as well. I know we were talking about on Earth with maps, we have degrees for latitude and longitude, but it's not the same in astronomy. So we have this concept called declination, which is measured in degrees, and declination is the position of an object in the sky above the celestial equator. So I talked about the celestial sphere, and if you project the Earth's equator out onto the celestial sphere, you have the celestial equator. And the angle above the celestial equator measures the declination. Now, the right ascension, though, isn't measured in degrees. It's measured in hours, minutes, and seconds.
Mm-hmm.
And so, if you like, zero right ascension is the first point of Aries. It's the position of the sun on the vernal equinox, the March equinox. And then the great circle, if you like, that runs around the celestial sphere is then split into hours, minutes, and seconds. So astronomers can quote the position of a point in the sky by giving its declination in degrees. But the other unit they'll use, they'll actually talk about how many hours, minutes, and seconds it is.
Yes.
And again, which seems strange, but of course, the motion of the sun around the Earth is very much connected with the concept of time.
Yes.
And so, degrees and the concept of hours, minutes, and seconds, they can mean similar things, which I think it's actually quite difficult to get your head around.
Yes, but there's something inspiring about it as well. I love it, although my brain is about to get really full. But what I also think is a beautiful link between these two fields, or between these measurements that we're speaking about, is these are the tools of exploration. This is how we discovered, in inverted commas, the new world. So again, being very Eurocentric, it is the ability to use angles to measure distance that allowed us to navigate the planet. And it is angles that allow us to navigate space, that we are exploring the frontiers of what we know about anything by sending out probes way out and beyond. And perhaps a lovely place for us to finish, so that I don't ask you yet another question, which they're all bubbling to the surface. Tell us about, there's the probe that is the furthest away from Earth at the moment. Tell us about the history of this. Yeah, because this is inspiring.
Okay. Now, this is where I'm worried I might get this wrong. There are, I guess, the really significant ones. We really talk about the Voyager probes here.
The Voyager probes, exactly.
Voyager 1 and Voyager 2 were launched in 1977, and they were designed to do something they called it the Grand Tour, which sort of is rather an exotic, romantic view. And people would go on the Grand Tour and sort of like travel around European cities or after the Orient. And the Grand Tour was possible because of a fluke in astronomical positions. And it just turned out that Jupiter, Saturn, Uranus, and Neptune were all on the similar side of the sun. And you can launch a spacecraft and you can fire its rockets and fling it away from the sun to the outer planets. But what was possible is that they can actually use the gravity of the planets to tug on the spacecraft, speed them up, and also point them off in the direction towards the next planet. And so they were able to investigate Jupiter, Saturn, Uranus, and Neptune in one mission. And it was rather lucky. This alignment of the planets, it only happens every few hundred years. And so they were lucky that this sort of happened. Voyager 1, that was the second one to launch, bizarrely. But anyway, Voyager 1 and Voyager 2 studied the Jupiter and Saturn. Voyager 1, after studying Saturn, flew away and off the plane of the ecliptic. They both are flying off the plane of the ecliptic, and they use the gravity of Saturn to fling the spacecraft off in the different orbits, so they can look closely at the moon Titan, I believe, as it flew past. And so the spacecraft Voyager 1 flew off out of the solar system at that point. Voyager 2 went on to discover Uranus and Neptune, and I believe it reached Neptune in 1989. People can double check my dates on this. So it was a 12-year mission, and then it flew past Neptune. Rather famously, Carl Sagan, once again, he lobbied for the cameras on Voyager 2 to be turned back towards the inner solar system, which it did. And it took this, he called it like a family portrait of the solar system, and the cameras looked back, and we observed the Earth as a pale blue dot, again, another one of Sagan's great sort of phrases. It was less than 1 pixel on the camera from Voyager 2. And some would say, well, scientifically, what purpose did this have? But it really gave the position and the planets in the solar system for this completely new, unique perspective. Anyway, Voyager 1 and Voyager 2 carried on flying away into space. There's no air resistance to slow them down, so that they just kept flying. They're powered not by batteries, but by sort of nuclear generators. There are plutonium power sources on board that generated electricity. So in the outer solar system, where it is incredibly cold and dark, they kept on working. And they are still working. And Voyager 1 is actually the one which is further out. They have now left the solar system officially. The sun produces this thing called the solar wind, which is a stream of high energy particles that streams out into space. And eventually you reach a point where the motion of these particles effectively stops as it comes up against interstellar gas and dust. And Voyager 1 and Voyager 2 have now left that point, and they are now officially in interstellar space. You know, humankind is an interstellar species. We've projected our technology beyond our solar system. And they are traveling out into space, notionally headed towards distant stars, but you know, they will take hundreds of thousands of years before we get to even the closest star. Even some of the fastest spacecraft we've ever built will still take insane lengths of time to get there. But of course, going along for the ride are these gold records, the gold discs that were placed on the side of the spacecraft. Once again, Carl Sagan comes into this. I would recommend any of his books, fiction or non-fiction, to everybody out there to read. And on the side of the spacecraft, there is a gold record, and imprinted on it are messages from Earth, of people from Earth basically saying hello. There's music on there. And they even put early digital encoding of pictures on there as well. And so, you know, our technology is slowly heading out into space. But of course, preceding all of that is our radio signals. You know, we've been transmitting primitive radio waves for more than 100 years now, and those radio signals have been heading out into space. And certainly anyone within 100 light years of Earth, light year being the distance traveled by light in 1 year. So anyone within 100 light years with a sensitive enough radio telescope could actually detect our early radio signals and sort of know that we are here. The great debate, of course, is there anybody out there to hear it? Well, again, we don't know, which is the greatest answer in science. Depending on who you talk to, then there may be very little intelligent life in the universe. But again, I think that conversation is definitely for another day. But the kids often ask me at school, do you believe in UFOs or do you believe in aliens? And I sort of said, well, UFO is just an unidentified flying object. So yeah, there are lots of unidentified flying objects. I went, do I think there's alien life out there? And I guess my answer is, I think there probably is. Being an empiricist, I don't know.
Yep.
But being a human being that actually sort of looks up in the sky and goes, wow, what is out there? I believe there probably is. I just hope in my lifetime I may actually get the data to back that up.
And there's some astrology to go along with you there too. And it's really interesting in sharing that story, Stephen, about the timing to release this probe, just what we're calling the luck of having those planets being in the right place to make such a valuable pass. You know, they could have all been dispersed in different areas across the ecliptic, and one probe just wouldn't be able to see them all at the same mission. You know, we just have to check one, or maybe we get a chance to check two. And these are the kind of things, you know, that astrologers are looking at when we do Muhurta, or when we do a chart for when is a good time for something to happen. We're doing the same thing that NASA was doing, a completely different level with a completely different purpose. But that sense of what is going on in our solar system environment it was really nice to have that link that for NASA, that was really important, because it made the timing so valuable. And I hadn't put together that fact. So lovely that you shared that, and so great to hear your passion about space exploration and the history of how that's been evolving. Stephen, it's been lovely to have you here on the podcast today. I still have more questions I want to ask about light. I want to ask about those telemic aspects that we didn't talk about yet. We're also got more to talk about with the location of north and south in the chart. So I really do hope that we will come back and have another conversation about the language that links astrology and astronomy. And if anyone is listening and they have questions that they would like explored, I'd love to hear them and see if I can get Stephen back on our podcast again soon. But for now, Stephen, thank you very much for being here.
It's been an absolute pleasure to talk to you as always.
Great. And thanks to all of our listeners for staying with us through the podcast. And I look forward to being with you the next time we're here on the Vedic Astrology podcast. Thanks, everybody.